let me just pause it for a second. Thank you so much, Jelina. Okay. Um, okay. So apart from the relational model, Pranay, yes, I will be uploading these slides and the other slides to Blackboard as well. These slides are not up yet, but I will be uploading them soon. Okay, so apart from the relational model, we also have other models such as the object model or object relational model or XML data models. But there are many other models that have been proposed over the decades. These models are quite recent. However, at the end of the day, relational models still stand strong and it is still the most used model across all databases. They still do not have any bite in the industrial sector, so to speak. Right. There are other simpler models as well that have simpler constraints compared to other strict relationship models. However, so for example, we can also have something like the NoSQL model or the NoSQL language that has a much looser definition about different key values and different structural relationships across databases. You can think about the relationship model as basically the most strict structured storage model that we have, and other models that have a looser sense of structure is basically um, would basically have a smaller subset of constraints than the relationship or the relational model. Okay, now moving on. So for this class, we will be working with SQL. After the first couple weeks, we will talk about how to install a SQL system on our systems and how to work with that. But for most of you, okay, so quick, type in the chat window if you have some experience with SQL or not. Yes or no? Like, have you ever done SQL? Have you never looked at it? Yeah, so yes, so usually that is the sort of variance between all students. So um, remember that for those of you who have some experience with SQL, remember that SQL and the relational model is not always the same. There are some things in SQL that are named the same, but they might not mean the same thing in terms of the relationship model or the relational model. So that usually ends up being an issue later down the course. You might say that that particular thing means this particular thing in SQL, but that might not mean the same thing in the relational model as well. So keep that in mind when we are discussing, and also remember that there are certain things in SQL that are more relaxed compared to the actual stringent relational model that we are going to talk about first. So keep those things in mind. Okay. So as I said, Ted Cord actually invented the idea of database management systems back in the 70s. Back in the day, before the 70s, people usually had a physical level design of how those data values would be stored. You can think of storing structures in C, maybe in a file system, and that becomes all sorts of exciting in that particular area, right? So we really do not want a person who actually wants to hold bank account details to figure out how a structure works or how a class works and how to actually store them in file and retrieve them and all sorts of irritating things, right? So it becomes quite costly, and that is why he actually came up with the idea of the relational model. And then IBM and Oracle were the first to implement the relational model back in 77. And from there onwards, it started to basically rapidly spread across the industry. Okay. So I've been talking about relational models, but what are relations in the first place, right? So relations are basically tables of data. So if you look at this particular data or this particular table, we will call this as a relation. Not exactly, we'll come to that. For now, let's just say that this is a relation, right? So a relation basically contains a bunch of data where each row of that table represents a particular record in that relation. And make sure to understand the individual terms that I'm going to use. When I say a record, I mean to say, if it was, of course, I mean to say a particular row of this particular table, right? That means a record or a tuple. We will be calling them tuples, but I'll come to that. Okay. Okay, fine. So a relational database is essentially a set of relations. And where does this term relation comes from? Essentially, this comes from the mathematical sense, where we say that certain things or certain variables are related to each other. So when I say that the first row or these rows are basically a relation, that means that the first value, which is, let's say that this is a table that has the account relation, that has the account ID of different people, the branch name of those different account IDs, and the individual balances of those individual, pardon me, account IDs. So we would want individual rows to be somehow related to each other. We want the branch name to be related somehow to the account ID of that particular person, right? We do not want individual rows to have content that do not have anything to do with each other across the entire column, right? So we say that account ID A307 is a branch that is in Seattle, and that particular account ID has the balance 275. So that is what we mean when we say that there is a relationship between all our rows or in a particular row, and that is what we mean when we say it is a relational data model, right? Okay. So relations have attributes. So sometimes these attributes are called columns. For this class, we are going to call them attributes. So attributes are essentially this column. So account ID is an attribute, branch name is an attribute, balance is another attribute. Each attribute is also named. So that means that each attribute would have its own name. And apart from that, each attribute would have its own domain. So a domain would basically be analogous to the data type of a particular variable. So what is the type of data that a particular attribute has? That is what we call a domain of that particular attribute. So an attribute is a column of a database or a relation, and the domain is the type of data that it can hold. Okay, so in this particular relation, that is the account relation, we have three attributes: account ID, branch name, and balance. The domain of balance, you can say, are all integers, or if you do not want to be a sucky bank, you can say that these are the domain of balance is all non-negative integers. We won't allow negative values, right? So those are things that you can specify in terms of domains when you're talking about databases and relation schemas. The domain of branch name would be, um, so now it would be an interesting example in terms of the differences between SQL and relational models. So in SQL, for those of you who know SQL, you can say that, okay, branch name looks like a string. So it can be a string of all characters that are less than 30 characters would be the name of would be a branch name. However, a relational model allows you to be more further strict about a branch name that can say that, yes, a branch name has to be a string, but it has to be the as a branch name that is from a set of all valid branch names that my bank
Hello?
has.
I think your
Hello?
voice.
Hello, what happened?
Oh yeah, I think you lost connection or
Okay.
something.
Okay, so Cox in, okay, yes. Can you guys hear me now?
Yeah,
Yeah,
we can.
yeah,
Okay.
we can hear you.
Yes, can you go back a little bit and repeat what you were saying?
I will. So as I said, attributes are individual columns. Each attribute would have their own domain. A domain is basically the data type of a particular attribute. And for example, this particular account relation has three attributes: account ID, branch name, and balance. The domain of a particular attribute would explain what type of data that particular attribute can hold. So for example, the domain of balance can be integers. However, we also want to have non-negative integers as balance for our, as the domain for our balance attribute, right? So for example, the branch name attribute. So for those of you who know SQL, would say that the branch name attribute would have the domain of strings that are less than 30 characters. but that might not always be so strict, right? So in essence, we do not want all possible strings under 30 characters. We want legitimate, valid branch names for a particular bank. So in a relation model, you can actually say that my branch name is going to be names from this list of approved valid names. However, SQL is not going to allow you to do something similar to that. It requires more work, but it does not allow you to do it implicitly, so to speak. So that is one difference between SQL and the general relation model framework. And there are reasons for why SQL will not allow you to do that implicitly, because of efficiency reasons and because of um, other reasons, for implementation reasons. So different SQL implementations, for example, MySQL and Oracle and things like that, have different implementation approaches. But in general, the basic framework of the relational model allows you to say that branch name has a domain that is a set of all valid branch names for a particular bank. Okay. Any questions so far? Okie dokie. Now, tuples. So each row in a relation is called a tuple. And I really do not want a war in my class to say whether it's called tuple or tuple. Pick one. Usually I'm going to call them tuple. A tuple is a fixed sized ordered set of name value pairs. So essentially a particular row is called a tuple. A particular tuple variable can uh, uh, refer to any particular valid tuple in a relation. So a relation is this table. Any particular valid row in this or a record in this particular table is called a tuple variable, right? Now, attributes in databases start at 1. I know this might sound weird coming from computer science background, but attributes start at 1. And basically that means that if we have a tuple variable t that refers to the first tuple of our account relation, so basically the first record here, that basically means that t of balance would be 350 and t of 2 would basically also be accessible, because we can also access a particular attribute using its index or its name. So we can access it using its name. So T of balance becomes 350. T of 2 becomes New York, because why not? Because it starts at 1. This becomes all sorts of exciting when you basically start using maybe JDBC, where you connect to a particular database using Java. Java uses indices starting from 0, but your databases start at 1. So that is all sorts of fun. But yeah. Tuples and relationships. So essentially, individual domains of a particular attribute would have certain possible domains. So basically, that is what we mean by a domain, that it has a possible restricted set of values that it can have. So if our account relation has 3 attributes, account ID has a domain of D1, branch name has a domain of D2, and balance has a domain of D3, then the Cartesian product or all possible combinations of those 3 domains would be where your account relation stays, right? So your account relation is essentially a subset of this entire Cartesian product. Okay. What else? So a tuple is a record and a relation is essentially a set of tuples. And I am being formal about this, and that is why we have underlined set. Can someone tell me the difference between a set of data values and just a general array of values or a vector of values? What is the difference between a set of values and a vector of values? Anybody? Any guesses?
A set has no duplicates.
Come again?